Hey guys, welcome back to another video. In this video, we'll be finishing where I left off last video, so we'll still be inside Unit 1, which is talking about limits, but in this video, I'll be introducing some new concepts about limits here, so let's jump right into the curriculum of what we're going to be learning today. So of course, as I already mentioned, we'll be finishing that example, and we'll be talking about the example where I left off on last video. If you haven't already watched that, make sure to go watch that, and then come back to this one. Then after that, we'll be talking about some properties of the limits and some requirements for a limit to actually exist. And in addition to that, we'll be talking about continuity. And then lastly, I'll be discussing techniques on how to evaluate a limit numerically. And by that, I mean when you get a function and the question asks you to evaluate the limit at a certain point, I'll be teaching you 3 different techniques on how to do so. Alright, let me get the example from last video up here again. So we had something that looked like this. We had a graph of function where f of x was equal to 1 over x. And of course, that's going to look something like this. Like this. Here we have this function again, right? So I asked you this question, what's the limit as x approaches 0 of f of x going to be equal to? Well, it may not seem as easy as it looks, because as I pointed out last video, the limit from the left direction, or the left side of the limit, is going to be negative infinity, and the limit from the right side limit is going to be positive infinity. So I left you guys off with the question, well, then what's the overall limit? Okay, well, now this brings me to some properties of limits. Props of limits. So I'm going to give you some notation. I'll be explaining this, so don't freak out on me here. So one property of a limit is that the limit as x approaches a from the right side of f of x is going to be equal to the limit as x approaches a from the left side of f of x. All this is saying is that the limit as x approaches a number from the right side of a function has to equal the limit as x approaches that same value but from the left side. So that graph, let me redraw this. It's a terrible graph, but you see what I'm trying to get at here. The limit from the left side is not equal to the limit from the right side. So in this case, we could say that the limit does not exist. DNE stands for does not exist. Okay? So then we get on to continuity. Now, it gets complicated here because when we have a function like this, this is actually called a discontinuity. But as I showed you in last video, you can still calculate the limit of this. The limit of this still exists, but there's a discontinuity. So there's certain types of discontinuities that will not allow for a limit to exist. Frankly, one of the most obvious examples is a certain case of vertical asymptotes as I presented in the last video. Here's a discontinuity at, well, not a discontinuity. The graph is simply not continuous at x equals 0. So what do I mean by continuity? Well, all I mean by continuity is the best definition for it is you have a smooth curve with no breaks in it, like this. Y equals x squared. Okay? You see here that for all x values, there's an output value. Therefore, the graph can be said, or it can be said that the graph is continuous for all input values, okay? Now, an example of a discontinuity would be something like this. There's a discontinuity here. Let's say that this is at 3. There's a discontinuity at x is equal to 3. Okay, because it's not smooth. There's a hole in the graph. Therefore, the graph is not continuous for all x values. Now, you can still find a limit with this kind of discontinuity. I'll be talking about what continuity implies in depth in the next unit, but for right now, just know that continuity is just having a smooth curve with no holes in it. If there's a hole in it, we can say that there's a discontinuity at a point, all right? So now, many questions on the AP exam will ask you to determine a limit numerically given a function, okay? Let's say that you have a question that asks you the limit as x approaches 2 of 8, that's an 8, minus 3x plus 12x squared. Now, this is the first method I'll be talking about in how to evaluate a limit numerically. This is called direct substitution. Now, frankly, this is going to be your easiest method by far. And because of that, you want to attempt this method first. Whenever you see a limit question, you want to attempt direct substitution first. If direct substitution happens to fail, like you get an indeterminate form 0 over 0, or you somehow get infinities in your numerator or denominator, then you can't use direct substitution. Then you're going to have to move on to some other methods. But even if you do get those forms, it'll still tell you some interesting stuff about the limit, which I'll be discussing in the next unit, as I said earlier. But let's talk about direct substitution. Now, as the name implies, all I have to do is just substitute in the x value that the function's approaching, or the limit's approaching, into the function. All right, so 8 minus 3, 2, plus 12, 2 squared. So this just becomes 8 minus 6 plus 12 times 4. So 8 minus 6 plus 48. So this is 2 plus 48. So the limit as x approaches 2 of this function, 8 minus 3x plus 12x squared, is going to be equal to 50. So there you go. So let's look at another direct substitution example. The limit as t approaches negative 3 of 6 plus 4t over t squared plus 1. Now we're going to try and substitute in t for negative 3 and see if we can get anywhere with that. Over negative 3 squared plus 1. This is going to be equal to 6 minus 12 over 9 plus 1, which is going to be equal to negative 6 over 10. Now this is going to simplify to negative 3/5. So it can be said that the limit as t approaches negative 3, the function 6 plus 4t over t squared plus 1 is going to be equal to negative 3/5. All right? Now, our second technique is going to be called factoring. So when direct substitution doesn't work and it fails, this is the next technique that you want to come to. So let's look at an example here. the limit as x approaches -5 of x squared minus 25 over x squared plus 2x minus 15. Now, even if you look at the function, you could tell that you could factor this down into more simple stuff. All right, so this numerator can simplify into x minus 5 times x plus 5 over, now let's factor out this quadratic. What are the factors? Okay, it's going to be x plus 5 times x minus 3. Now, you see how there's an x plus 5 here and an x plus 5 here? We could just cancel these out due to properties of fractions. Now we have the limit as x approaches -5 of x minus 5 over x minus 3. So now, as you guys might notice, we could actually try direct substitution here. So you may be asking yourself, well, you started this limit using the factoring technique, so shouldn't you finish using the factoring technique? No. The factoring technique's only used to make a limit look simpler. So right now, this is as simple as a limit can get. So after you go through the steps of factoring, that's when you want to retry direct substitution. And in this case, direct substitution actually does end up working. So we get -5 minus 5 over -5 minus 3. It's going to simplify to -10 over -8. And this is just going to simplify to +5 over 4. So the limit as x approaches -5, x squared minus 25 over x squared plus 2x minus 15 is going to be equal to +5 over 4. Now, I'm going to be talking about the last technique that you'll be learning in this video. This last technique is called rationalization. Rationalization. Now, this technique is going to be the most time-consuming, and there's a lot of algebra that goes on here, so it's very possible for you to make a mistake. So consider this and think of this as your last resort technique. Only use this if direct substitution fails and factoring fails. And you'll see why I'm saying that. Let's look at an example to present this. The limit as x approaches 4 of the square root of x minus 2 over x minus 4. Okay? Parentheses around this. Now, whenever you have a square root and your other two techniques fail, you always want to think of conjugation. Sorry, not conjugation, multiplying by the conjugate. That's what you want to always think about. So we have a radical here, so we want to multiply this by its conjugate. So it's going to be the square root of x plus 2 over the square root of x plus 2. Now, if you simplify this, this is just going to be x minus 4 over x minus 4 times the square root of x plus 2. Now, the reason why I'm not foiling out the denominator is because often in rationalization, things will actually end up factoring out, so we want to leave it in its most factored form to begin with. And in this case, things do end up canceling out. We get an x minus 4 here to cancel out the numerator and the denominator. So now we're just left with the limit as x approaches 4 of 1 over the square root of x plus 2. So now, as you can see, we could actually use direct substitution here. The limit as x approaches 4 of 1 over the square root of 4 plus 2. This just becomes 2 plus 2, 1 over 4. So this is going to be the answer for our limit right here. All right, now let's get one more example on the board right here. The limit as x approaches 0 of x over 3 minus square root of x plus 4. Now, as you can assume, direct substitution will not work here, and factoring will not work here, at least as of right now. So let's multiply this by its conjugate. 3 plus x on the square root over the same thing. So this just becomes x times 3 plus x plus 4 over 9 minus x plus 4. This implies to x times 3 plus x plus 4 over 5 minus x. Okay. So we can actually attempt direct substitution right here. Okay. So if you substitute in 0 for x, you just get 0 times 3 plus square root of 4 over 5 minus 0, that's just 5. So obviously it's going to become 0 over 5. So the limit of this is just going to be 0. Alright guys, we reached the end of the video here. I'll most likely be wrapping up Unit 1 limits in the next video. I'm sorry I couldn't get to everything. I wanted to keep this video short. But don't forget to subscribe, like, and follow the official School Breeze on TikTok for some more short and interesting content. I'll be posting some short video clips on there as well. So make sure to go follow that. And I'll see you again next time.